Hello and welcome to the Geocurrents lecture series on global demography. Today's lecture is going to look at the demographic transition model. It's a relatively short lecture, I should add. This model is indispensable, but I would also argue that it's quite flawed, and I will outline some of those flaws in this lecture. Here's an essential graph of the demographic transition model as it was originally formulated, derived from the Wikipedia page on the model. So it has this four-stage system. You start with the pre-industrial stage, regarded as universal across human societies, where you have high birth rates and high death rates, which means the population is going to remain relatively steady. If it expands, it will expand slowly. And you can see on the graph here, the death rate is shown as fluctuating, but the birth rate is shown as essentially constant. And then the transitional stage occurs after the development of modern medical advances, which reduce the death rate. You can see it dropping quite sharply, also coming from increased food supply. And this is the period then of rapid population growth. And then you reach the industrial stage where the birth rate is going to decline, as the graphic here notes, due to increased opportunities for women and access to birth control. There are actually many other factors involved. That's quite a simplification. And then you're going to reach stage 4, the so-called post-industrial stage of population stabilization, where you're going to have death rates and birth rates both relatively low, leading to population stabilization. And according to the graphic here, the birth rates are going to be fluctuating to some degree, but the death rates are going to be remaining essentially constant. Recent changes or developments, I should say, have led to the addition of a stage 5. And here we see, again, a Wikipedia graphic of the demographic transition model with this stage 5 added. Interestingly, however, on this visualization, stage 5 is shown as uncertain, yet to be seen, with the birth rate either falling further or possibly rising again. The death rate is to be low, and the natural increase is going to be little change. I would change this a bit. It definitely seems to be that what we're seeing in most countries of the world, just a few exceptions, is that a stage 5 is going to be characterized by lower birth rates. So I put a yes and a no in there. It would be characterized by extremely low birth rates in many countries, below 1 child per woman in some cases. The death rate, I would note, would be rising, because you're going to get a rapidly aging population. So with rapidly aging populations, you're going to have a much larger cohorts of elderly people, so the death rate will rise. And then the natural increase is going to be, when I say inversion, which I mean is population decline. Now, that can be counteracted by immigration in some countries, but eventually that's going to run out, and we're going to get population decline across the board, at least if the current trends hold, and we don't know if they will, but that is certainly what is happening now. So we have also here the population pyramids, characteristic of each stage, and the one for stage 5 actually shows the possibility of a flaring out at the bottom. In other words, more children being born, which is a possibility, I will certainly admit, but we're not seeing that. Certainly a country like South Korea, which probably has the lowest fertility rate in the world, the population pyramid is not shaped at all like a pyramid. So just to explain how these population pyramids work, we have age cohorts here, basically each year. So we have that bottom line, blue for the male side, pink for the female side. That's just the number of people age 0 to 1. And then we're going all the way up to age 100. Also, you can see darker blue on the left-hand side of that graphic from age 20 up to about 35 or so. That reflects excess men over women. South Korea traditionally had male bias and had like China, more abortion of females. That really is no longer the case, so you don't see much at all. It's just a little bit of excess male population. And actually, there are a few more boys generally born than girls, partly because boys have a higher mortality rate. And then you can see a large female excess at the upper ages because women outlive men in South Korea, as in most countries. And just note the difference between the birth rate, 4.5 births per 1,000 population, versus the death rate, almost 7. So even though we have a relatively high life expectancy, it's not going up very rapidly at all. It's pretty much reached its limit. Well, it could go up to some degree, but that means that South Korea is soon going to be having a rapidly decreasing population that potentially could be made up by immigration, but that's not happening to a very large degree. And it's interesting to compare a country like South Korea with its population pyramid to a country like Niger in the Sahel belt of Africa, south of the Sahara. This is not exactly a pyramid either, partly because of a relatively high death rate and low life expectancy. You can see life expectancy only of 60 years. So some people are living to old ages, but not that many. So it's a very much a pointed sort of shape. And then you can see the huge bulge at the bottom because of the very high birth rate. It is declining, but it's still quite high. And so you could see the birth rate of 47 births per 1,000 population and the death rate of only 9.87. Now, there's been quite a bit of scholarly work on the idea of a second demographic transition, which we could say is essentially stage 5. And this came about in the, I think it was first hypothesized in the 1990s. But the idea behind this, really based on the European experience, is that in stage 5 or in the second demographic transition, you're going to have huge changes in family types. You're going to have very low fertility, which is what we have seen, but a diversity of union and family types. This is the graph on the left just shows the idea of this, decline in first marriage rate, increase in mean age of marriage, strong increase of divorce, strong increase in cohabitation, rise in births out of wedlock, use of more effective contraceptive methods, all of these pushing the fertility rate down. And some of these things have been seen. Some of them have gone into reverse. Certainly, we don't see a continual rise in the divorce rate, for example. Many countries have seen a very large increase in births out of wedlock, but it's really quite uncertain whether these are going to be continuing trends. The article on the right, more recent, I'll just read the conclusion here. Social demographers should explore theory not anchored in stages and one that does not posit a unilinear developmental pathway towards some end stage, as in the case of the second demographic transition. One assumed to look like the advanced Western countries, most accepting of postmodern values. And I think that's spot on. For example, we could look at a country like the United Arab Emirates, and it has an extremely low total fertility rate now, 1.21 children per woman. And you can see how it dropped quite precipitously after about 1975. The United Arab Emirate, just a little bit of background, it's a very wealthy country in the Arabian Peninsula. Has 7 constituent emirates, the most important of which are Abu Dhabi and Dubai, a major oil producing region and a major trading center as well, those 2 large cities. But I don't think anyone would argue that the United Arab Emirates is characterized by postmodern social values with this, as described in this second demographic transition theory, which is really based, as I mentioned before, on the European experience. So let's outline some other problems with the overall demographic transition model. So stage 1, supposedly characterized by high birth rate, high death rate, stable or slow population increase. Well, I won't argue that the societies before modern times were generally characterized by high birth rates and death rates. That's undeniable. But the stable or slow increase did not apply everywhere. It certainly did not apply in areas of frontier settlement with abundant resources and low or non-existent population density. We don't have real solid information, but it certainly looks like when the first human beings came to places like New Zealand and Madagascar 1,000, 1,500 years ago, they experienced very rapid population expansion. Or even in the Americas, when you had the indigenous population, which in many areas, not all, but in what is now the United States, was relatively sparse to begin with, and then suffered a massive die-off, mostly due to infectious diseases, but also to the activities of the colonialists. But that did mean that the settler colonies had abundant land and resources, and their population expanded very rapidly. Yes, you did have a very high death rate. Almost half of children would die before they reached the age of 5, but with birth rates up to 8, that still meant possibility for exponential population growth, which Benjamin Franklin talked about and to a very large degree was occurring. And we could talk about similar episodes of rapid demographic natural increase, if you will. So it was not uniformly stable or slowly increasing. Actually, what was a lot of fluctuation. Well, we'll look at this with the next slide. So I crossed out stable or slow increase because I'd say really it was fluctuating during periods of plenty and periods of crisis, something that Thomas Malthus wrote about a lot. And I think, again, this is quite undeniable, essentially, if you actually look at the data we have on pre-industrial countries. It wasn't a situation of population stability. There were lots of ups and downs, and both the birth rate and the death rate especially would vary quite a bit. Also, there's problems with the birth rate being high, and I crossed it out and said added sometimes moderate, because we do know that some stage 1 societies limited their fertility. We've seen this very clearly in ancient imperial Rome, especially for the elite, but for others as well. For Japan in the 18th century, undeniable. France in the 1700s, early 1800s, we had societies where the birth rate was very much limited through a variety of different means. I don't have to go into that now, but the idea that all societies had the sort of same kind of birth rates and that these were uniformly high, it just doesn't fit the evidence that we have. Another problem, and maybe this is petty for me to bring up because it's a problem for any sort of theoretical model like this that posits these smooth curves, where when we actually look at the data we have, we see, again, these ups and downs. There are massive events that occur, wars, famines, plagues, these sorts of things, and it's very difficult to factor these into these sort of theoretical models, so you don't see that much. So it's misleading. For example, periodic mortality crises are generally not foreseen and really sort of can't be foreseen. A really interesting case here is Botswana, a relatively sparsely populated country in southern Africa, but also one that's often viewed as a real sort of developmental model. Botswana has very competent government, low rates of corruption. It has a lot of natural resources, particularly diamonds. And the government has been able to use the revenue from those resources to institute programs for broad-based social and economic development, relatively high rates of education. And you can see on the graph, life expectancy was really increasing in Botswana from 1960 to about 1985, and then plummeted from almost 64 down to about 48, 49 or so. And this was because of the AIDS crisis and because of the development of effective medication against AIDS, the life expectancy was able then to resume its upward trajectory. But it wasn't given that AIDS would occur, nor was it a given that AIDS could be cured. So these sorts of crises occurred not just in the pre-industrial or primordial period, whatever you want to call it, but still occur today. Here's another example, the so-called Russian cross, which occurred in around late 1980s, early 1990s, where the death rate exceeded the birth rate. So you can see the birth rate really dropping during this period and the death rate really increasing. This had to do with the economic and political crises really that occurred with the collapse of the Soviet Union. And this was a period of tremendous uncertainty, and people's livelihoods were falling apart. There was a tremendous amount of despair. Rates of alcohol consumption and alcoholism among men in particular rose drastically, and you could just see this crossing of the birth and death rates again, which occurred very quickly, unanticipated, not factored into any of these models. And certainly the demographic transition model, it doesn't take into account any social, cultural, or political differences. All countries are put in the same category. All that matters is food supply and medical changes and so on. People are seen as sort of behaving in a universal pattern, and that doesn't happen. I'll just take two European countries as an example and give the total fertility rate of Sweden and Spain here. If you look, you have to look carefully to see that the scales are somewhat different, where for Sweden 1.4 is the very bottom rung, and 1, that's children per woman for Spain. But anyway, you could see that Spain had much higher fertility rates initially. Sweden dropped much more quickly and then had these more ups and downs. And now birth rate of Spain is well below that of Sweden. And they are very different cultural environments and political environments as well. I think, as I mentioned before, many scholars have speculated that one of the reasons why you have these very low birth rates in southern European countries like Spain, Portugal, or Italy is you have a cultural situation in which men are not expected to do as much child care as would be the case in Scandinavia, which has had more sort of cultural change in this regard and more parental or more involvement from fathers. And that's arguable, but the cultural differences between those two countries are undeniable. It's interesting, we could take North and South Korea, which started out as two countries with the same culture after the Korean War when they were divided, but then divergence across the board, economic divergence, political divergence, and cultural divergence as well. And you can see this is reflected in the birth rate. Begin with, back in 1960, South Korea had a higher birth rate. South Korea was the less industrialized half of the peninsula. All of Korea had been under Japanese domination from 1910 to the end of World War II. The Japanese, unlike Europeans, tended to industrialize their colonies for the benefit of Japan, not for the people living there so much. But the industries were located in the north. That's where the main mining and steel mills and manufacturing centers were located. It was more industrialized. The south was much more rural, had a higher birth rate. And then you could see the changes going on with the North Korean birth rate. Then as North Korea had economic decline but increasing grip of totalitarian politics, its birth rate actually went up a bit. South Korea simply went down. We have a situation now where North Korea is well ahead of South Korea, although it's debatable how far ahead it is. For a long time, North Korea was maintaining a birth rate of around 2, essentially the replacement level. But it has dropped. According to the UN, it's now down to 1.8, although there are some scholars who think that it's dropped much more, maybe as low as 1.3 or even 1.1. Now, that's still much higher than South Korea's, which is like 0.7. And as an overarching point, I'm going to quote here Jane Falkingham of Southampton University, who noted that we've got population projections consistently wrong over the last 50 years. And I think this is really undeniable. And we still have these very confident projections being made. And then within a few years, they have to be recalibrated because they are not working out. So as she notes, we have not been good at spotting trends in fertility, and that's absolutely true. And then she notes a 2004 United Nations publication for guesses of the global population in the year 2300. And of course, this is just pure guesswork, and we have a low estimate of 2.3 billion and a high one of 134 trillion, which is, of course, is as absurd as the people who came up with that projection fully knew. So we have this illusion of being able to predict what's happening and what's going to happen in the future. And I should say, too, the farther into the future, the more these projections become pure guesswork. Also to note, demographers have not even been good in anticipating improvements in infant and child mortality. It was not expected that infant and child mortality would drop as rapidly as it did. So we can see on the graph on the left here for different regions of the world, under age 5 mortality in 1970 and then 2015. And you could see in sub-Saharan Africa, which has by far the highest infant and child mortality today, 83 per 1,000. That's pretty high. Remember, though, in even the United States, it was 440 back in 1800, and that drop from 244 to 83 is quite impressive, and it has continued to drop since 2015. You can see this in the graph on the right with Uganda, which goes up more towards the present, and we can just see this continuing fall. And it's true in other regions of the world as well. A lot of this is from the development of relatively inexpensive oral rehydration therapy, because most infant mortality is coming from dehydration due to diarrhea from various diseases. And you cannot simply rehydrate an infant or a small child by giving them water or milk. You need to get the electrolyte balance right, but that's not very difficult to do, and it has been done very effectively in many areas. And when you decrease the child mortality, you're going to first get a surge of population growth, but then there's generally going to be a fertility response as people calibrate the number of children they're going to have based on the survival of their children that they do have. Another problem that demographers had was a view back in the 1990s that the demographic transition was simply not occurring in Africa. So here we have an editorial from Population and Environment by Virginia Abernathy, 1993, noting that African fertility, which had been moderate, zoomed up to 6 or more children per woman in the same time, 1960s, as infant mortality was drastically reduced. Healthcare availability increased, literacy for women as well as men was rising, and general economic optimism pervaded more and more sectors of their societies. And there's definitely a degree of truth in this. Fertility rates did go up. At the same time that infant mortality rates were declining. And so there was real concern that, well, Africa is just not occurring. This demographic transition is stuck. And if you look at a fertility graph of a country like Niger, it's showing, I've cut off part of the graph at about shortly after the year 2000. But we see in 1975 a real uptick in the fertility rate. This was, again, as conditions were improving. So it did look stuck, but it doesn't look stuck anymore. So if we take that graph all the way to its end here, we can see it's still high. Fertility rate in Niger, it's still rapidly growing, and there's still a lot to be concerned about. Niger is a country at the edge of the Sahara, prone to famines, questions about whether it has an adequate resource base to maintain the population it is soon going to have. So the question is this pace of fertility decline rapid enough? And I don't think we know the answer to that. And it's not just Niger. We can see this in many other African countries. You could see Mali. It's pretty much across the board that you did get this drop in fertility. It came later. The shapes of these curves are different in different countries, but the general downward trajectory is pretty much everywhere. And as I mentioned in the first lecture, in this series, we've also seen this odd fertility rebound in some countries, particularly Central Asia. And I have here Kazakhstan and Mongolia. Kazakhstan, a predominantly Muslim country, Mongolia, predominantly Tibetan Buddhist country, so very different in their cultural background, although there are certainly similarities as well. But in both of these cases, well, Kazakhstan had been part of the Soviet Union, Mongolia had been essentially a Soviet satellite. And fertility rates had really dropped precipitously, especially near the end of the Soviet period, but then they have had a certain rebound. I'd also note these are both sparsely populated countries, and so there's relatively little worry about them having excess population. But they have had this very interesting fertility rebound. I don't think that has been adequately studied. And then I'll note just a couple more slides here that demographic change can be much faster than we have expected it to be. And it's interesting, here's an article from physics.org from a few years back, why we think the demography is a slow thing and why we are wrong. So the scientific literature has considered population trends as slow, with fertility and mortality driving long-term changes that are fully appreciable in generation-long periods. But the article goes on to say that no, it can happen fast. And that's one thing that I really want to emphasize, and I will in the final lectures of this series, is in just the last couple of years, many countries have just seen just really rapid drops in fertility. I'll talk at some length in a later lecture about the country of Chile, which really typifies this just sort of the bottom falling out of fertility. And again, unanticipated, hard to explain. I will do my best to give some possible reasons. But then finally, to conclude, for all of that, the demographic model still works reasonably well for the world as a whole. So I just have here total world fertility rate here. It only goes up to 2010. It's now right about at the replacement level, maybe a little bit above. And then contrast that with a graph graphing total fertility against the Human Development Index, this comprehensive UN index that includes education, health, economic development, and so on. And you can see there's big gaps between countries at the same level of HDI, fertility gaps, but the general trend follows that line on the left. And so as an overarching model, the demographic transition model, especially if we add a stage 5 of very low fertility, it's the best general model we have. I don't know what would replace it, but these sort of models always have to be taken with a strong degree of skepticism because they can approximate what's been happening, but they're definitely not going to pinpoint it or explain it. So thank you. The next lecture is going to look at these rapid drops in fertility, especially in the United States, but in other countries as well, and try to offer some possible reasons for why it's happening. A lot of controversy there, of course. So thank you, and I hope you tune in. There will be 2 more lectures in this series.